Okay, after much thought and planning, I've decided to start all of my videos with a joke. But you have to wait for the punchline until the end of the video. So my first joke is, why are math teachers so stressed out? Alright, we'll come back to that. Alright, today's lesson, using similar right triangles. And I have visual aids and manipulatives. You're not finding this in a textbook, kids. Alright, so the whole basis of this lesson is this idea that if we have a right triangle and we drop an altitude from that right triangle to the hypotenuse, we create three similar right triangles. And we explored that in class, so hopefully you're already familiar with that concept. The three triangles are, let's just do it in Miss Sissy's talk, the big one, this medium one, and this small one. Okay, Papa Bear and Mama Bear and Baby Bear. And we're going to look at that a little bit closer. So the first triangle, because the hard part about this stuff, I think, is writing similarity statements and lining up those vertices in the right place, in the corresponding places. So I'm going to write them first and then try to show you how they line up. Triangle CBD, the little one, is similar to triangle ABC. The right angle is always in the same place, and I have fancy stuff here. So here's the big triangle, and I put the labels for the vertices like in the inside, which isn't really the best place to put them, but it works, okay? And then here's this guy, and here's this guy. So this is C, C, C. That's the vertex C. So triangle CBD, CBD is the little guy, and ABC is the big guy. Why are they similar? Because if I move them around, if I go, okay, they both have a right, oops, I lied. Let's flip this one too. They both have a congruent angle here, and they have a right angle here. So D and C should be in the same position. They are. B and B should be in the same position, and they are. And A and C should be in the same position here, and they are. Okay? Alright. Next one. Triangle ACD is similar to triangle ABC. ACD is my medium triangle. Mama Bear. Alright, ACD to ABC, the big one. So the medium's similar to the big one, right? But let's line it up so that the right things are in the right place. Again, I'm going to flip that big one, and line it up like this. So my right angles are in the same position. Hopefully D and C should be in the same place. They are. C and B should be in the same place. They are. A and A are in the same place. They are. And again, they're all similar by AA, or by AA, because we've got congruent angles here and then congruent right angles here. Okay, and then the last one are the medium and the small congruent to each other. Triangle CBD, similar to triangle ACD. Again, the order of these vertices matters. So here's my medium guy, and here's my little guy. And if we line them up in the right place, D and D, my right angles, C and B, and A and C. Okay? So let's use that to just solve a problem. So here's an example of something you'd have to do to show that you understood that. Okay, so if we have a drawing like this, okay, right triangle, dropping an altitude to the opposing hypotenuse. We're going to call this triangle EFG, and this point here is H. We're going to call this distance X. The legs are 3, 4, and the book gives us this, but boy, we should know it, right? The hypotenuse is 5, because it's a triple. 3, 4, and 5. So the first question I'd ask you, or our book asks you, or I might ask you about this, is name the three similar triangles, or name give me a similarity statement about the triangles. And this time let's just put all three in a row. Our book does this, so I guess it's okay to do. We've got the big triangle, similar to the medium triangle, GHF. I'm going to once again show you this with manipulatives too, and then to the small triangle, EHG. The tough part is knowing how you have to flip these around and do some things. So I did another drawing again, white on white, hopefully you can see. So there's the big triangle with distances put in here and vertices. My medium triangle right here, and little, I made them the same color. Hope that's okay. Okay. So the similarity statements, E to E. I think I'm not going to go through all these. It's the exact same process of what I did before, but I am going to use these to help me solve for x, which is part 2 of this problem. We might ask you to say solve for x. Knowing all this, solve for that altitude. So let's think through the similar triangles. We've got, in the small triangle here, we've got hypotenuse to long leg, and in the big triangle we have hypotenuse to long leg. Again, hypotenuse to long leg is the same as big triangle hypotenuse to long leg. Let's look on here. Big triangle, 5:4. Small triangle, lining up the right angles, the corresponding parts here. Big triangle 5:4 as 3:x. Hypotenuse to long leg is as hypotenuse to long leg. And there's my proportion. And from there, we just use cross products property. 5x equals 12. X equals 12 over 5. A couple other theorems we're going to look at with these similar triangles that are formed in this special situation. So one of them is called geometric mean. They're both called geometric mean theorems, but geometric mean, the first one uses an altitude theorem. Now your book has an awful lot of text and information about this, but I needed to see it in a simpler way. So here's how I'd like to present it. So again, here we got that. You're going to all make fun of me for saying it, but we got Papa Bear here, the big triangle. And then when we drop that altitude down, we have the mommy and the baby bear. This altitude cuts this hypotenuse, we're going to call this distance A and distance B, into two segments, A and B, and we're going to call the length of the altitude x. And there's a special relationship that's formed because of the similar triangles, that this altitude is the geometric mean of these two distances. So we can set up a proportion. A is to x as x is to b. So because we have this proportion, let's think through the triangles. Long leg is to short leg in mama bear, right? Long leg to short leg. In baby bear, long leg to short leg. Long leg to short leg. Long leg to short leg. Once you start getting familiar with this, so you kind of just see it like that. That cuts it. A is to x as x is to b. That's how I start to see it. Miss Trace and I were talking about this. She kind of always visualizes those three similar triangles. I just sort of see that this cuts it into segments with this being the geometric mean. And again, let's apply that in a problem. So you've got, again, right triangle. This guy's right, and this is the altitude. We'll call this x. This distance of 4 and this distance of 9. This altitude is the geometric mean of these two new segments that are formed. Again, it has to do with the similar triangles. 4 is to x as x is to 9. Long leg to short leg, long leg to short leg. Or short leg to long leg of the little triangle, short leg to long leg of the medium triangle. X squared equals 36. X equals 6. One more that works sort of like this one. Another geometric mean, but this time we're using a leg theorem. Have I mentioned in this lesson, sorry, that there aren't any proofs with this stuff. We're not going to have you do any proofs with this. We're just going to have you solve algebraic problems based on this. So going back to our drawing of our right triangle with an altitude dropped. This time we have a special relationship between, we'll call this long distance here, C, that long hypotenuse of the big triangle, and then we're going to call this D. I'm just going to try to, so that distance right there is C, and this is X. This distance right here is the geometric mean of this and this. So let me write the proportion and then talk through it. C is to X as X is to D. I just used different letters to have it different from the last example. The hypotenuse of the big triangle is to the short leg as the hypotenuse of the little triangle is to the short leg in the little triangle. One more time I'm going to say it. Hypotenuse of the big triangle is to short leg of the big triangle as hypotenuse of the little triangle is to short leg of the little triangle. And then that X is the geometric mean, which we learned a few lessons ago. Last problem, I'm just going to show you how this would work in action. Let's say we've got triangle here, right angle, drop in altitude over here. And we'll call it L, J, K, M. Let's have this whole distance here be 24. And this distance here is 9. And this is Y. And we want you to solve for Y. Long distance, it's 24 is to Y as Y is to 9. Hypotenuse of the big triangle to short leg of the big triangle is the same as, is proportional to hypotenuse of the little triangle and short leg of the little triangle. And then it's that Y is the geometric mean. I'll do this math here for you. 216, and we're going to give our answer in simplified radical form. Why are math teachers so stressed out? Because they have to deal with so many problems.